So watched the what I was working through, it was all scrambled. But if you were taking notes and if you're trying to complete, I hope you did that. And if not, you please do it now. At the end of the video, from whatever you can scramble out of that and complete the process. Okay, write the full integral, and here is your final answer after you simplify. Okay, check that. And if you don't get the same answer, you can let me know. We can talk about it. We can see where you might have missed anything. And in the final answer, I want to point out two things. Here you see that after you take the common denominator in the numerator and denominator, it will get simplified to that. And similarly, there was a 3 at the front coefficient. Don't forget that. Sometimes we do small parts of the problem and then we miss what was some components we might miss. Okay, make sure that you didn't miss that, and which makes it 2 root 3, the coefficient. Okay. And the second thing I want to point out is these absolute value signs, I just dropped them and wrote parentheses here because while doing this, the first integral, I realized that that whole expression can be written as x plus half whole squared plus 3 over 4, right? And that can never be negative. It's a square, perfect square, which is positive, plus 3 over 4, and because it can never be negative, for any x, I don't need to write the absolute value sign anymore. Okay. All right. Some more problems I'm doing in this video as well. Some simple, you will see that, we will alternate between simpler ones and challenging ones. Okay. This is a simple one. The denominator is already factored for you, x times x minus 7. So you just say let that 1 over x times x minus 7 equals a over x. Because the denominators are linear, the numerators have to be constants only. There is no other choice. Can you just make a wild, like in a simple prediction and get this done? Yes, you can. Okay. And I think I spoke that about in class also. For those who are watching only the video, you can see how I will do it. Okay. I will write 1 here and I will write minus 1 here because I know what's going to happen when I do that. When I try to combine them, it's going to be x minus 7 minus x, right? The reason of writing minus is the x and x will cancel. But then I will have minus 7 in the numerator, right? Which means I need to have that to balance it out. I need to multiply this whole thing with 1 over minus 7. So I'll have 1 in the numerator, that is basically the factoring. But sorry, I should not have written it that there. I know this is going to be my final answer. I'll write it here. Or not even here actually. Let me make it smaller and drag it somewhere here on top. Okay. Let me see if I can change its color to something more visible. Okay. I'm expecting that to be my final answer. But let us do it systematically through partial fractions. Equals a over x plus b over x minus 7. So when you take the denominator and multiply both sides, or multiply both sides by this whole denominator, x times x minus 7, you will get 1 equals x minus 7 will survive with a, x will survive with b. Okay. Now you want to get the values of a and b. You want to obtain the values of a and b systematically, right? So you put the values of x, because this should work for any value of x. You can choose whatever you want. So I'm putting x equal to 7, let's say. And why do I do that? That will give me 1 equals a times 0, right? Plus b times 7. So you can see that b will be 1 over 7. Okay. And if I put x equal to 0, and why do I do that? Because that will produce 1 equals a times minus 7 plus b times 0. And you can see that that gives you a equals minus 1 over 7. Okay. So therefore you can say, as a conclusion, in conclusion you can say, therefore 1 over x times x minus 7 equals a is minus 1 over 7 and b is 1 over 7. And that's the same thing that we have here if you distribute that minus 1 over 7 inside. Okay, done. Once you're done with that, then you can do the integral. Okay, so let's apply the integral now on both sides. Dx, this whole thing dx. Okay, what does that produce you? Minus 1 over 7 ln x plus 1 over 7 ln x minus 7 plus constant. Okay, now you'll see the answer is not one of them, right? Answer is something else. That is because they have taken 1 over 7 as common factor and written as ln x minus 7 minus ln x, right? X has negative coefficient plus c. So if you combine them, that will become divided by x here. Instead of that, and whole thing in parenthesis, and x minus 7 over x, you can see here the first answer. Okay, and 1 over 7, right? The fourth answer also has that, but the coefficient is not correct. It's not 7, it's 1 over 7. First option is correct. The middle ones, the expression is not correct. It's not x square. Okay. All right, that was one problem. Let us look at another. And again, you see, this is proper. Degree of denominator is more, right? So you can only I mean I'm only talking about the partial fraction part. Okay, the denominator x square minus 5x minus 6, you have to first check whether you can factor it or not. Okay, previously we had x square plus x plus 1 and I had mentioned that it cannot be factored, right? So we had to leave it as like that. But every time you have to check x square minus 5x minus 6. Think about it. You can factor it and it will be x plus 1 x minus 6, right? So that is a over x plus 1 plus b over x minus 6. Two linear things. Okay, because it is proper, by the way, please note that. Okay, so I didn't have to do any polynomial division. I can factor the denominator, then write it in that form in the partial fractions, and then cross multiply. 3x minus 11 equals a times x minus 6 plus b times x plus 1. Okay, always, whatever factor that particular term has, whatever denominator, a over x plus 1, right? It has x plus 1, so that will get cancelled and the x minus 6 will survive because you are taking the denominator from the left and multiplying it, on the numerator on the right side. So whatever the denominator it has, that will get cancelled and everything else will be, attached to it as a factor. That is the simple way to write that. Now to get the values of a and b, please follow the technique that I did before and do it and check with me. First you should put, let's say, 6. That gives you 18 minus 11, 3x, right? Minus equals a times 0 and b times 7. 6 plus 1, 7. 18 minus 11 is 7. So 7 equals 7b, gives you b equals 1. Okay. Next, you put x equals, you are thinking correct, minus 1. Okay. And that gives you minus 3 minus 11 equals a times minus 1 minus 6 plus b times 0. Minus 1 plus 1, 0, right? Minus 14 equals minus 7a, gives you a equals 2. Okay. So therefore, you can say, this integral that you are doing here will be equal to a is 2, right? 2 over x plus 1 and b is 1 plus 1 over x minus 6 dx. Okay, so that is 2 ln x plus 1 plus ln x minus 6 plus constant. Now check which one of them matches here. 2 can go inside and become square, right? Okay, when it goes here, it becomes square. And then you merge them, you will get x minus 6, x plus 1 squared. We're putting in parentheses. I'm doing that. You don't have to do, okay? If you are writing a free response answers, this purple, or say this violet color here would have been your final answer. You would have left it at that. Even 2 with the coefficient, not squared inside, okay? But in a multiple choice, you want to choose the correct response. So I'm doing it, in that form. Right? Then you see that this, oh no, I'm sorry, not that, here. That matches. Okay. All right. One more. And now you can see that is improper. Whenever you check the degree of numerator and denominator, right? That's improper. Okay. And here you can do polynomial division, but I'm going to follow the second method which I was showing earlier, because you can kind of see it very clearly here. Okay. X cube minus 2x square in the numerator and x cube minus 2x square in the denominator. They're already almost matching, right? So why to go through the full polynomial process? You can simply write plus x, so it matches exactly with the denominator, plus 4x minus 2, right? I had this 5x, which I have to split into x plus 4x. That's called rewriting, okay? I'm cleverly rewriting it so that I can And the denominator can be like, the whole expression can be split into two rational functions like that by distributing the denominator. Okay. So this whole thing, as a result, I can write this as integral of 1, the first part. Okay. Numerator and denominator cancels. You get 1. This whole thing cancelled 1. And plus 4x minus 2 over x cube minus 2x square plus x dx. Okay. Now you have a proper fraction. This is proper rational function, and it has a denominator x cube minus 2x square plus x. So now you have to think of partial fractions. Okay. So to do that, first we are going to look at x cube minus 2x square plus x, the denominator. To obtain the partial fractions, you need to factor it, right? And find what are possible factors, or that there are none. And you can easily see that x can be factored out. And then when you see that x square minus 2x plus 1, you should be able to see that it is x minus 1 whole squared. A square minus 2ab plus b square. Okay. So that means you have to let, okay, that 4x minus 2 over x, actually let me write the factored form, x times x minus 1 whole squared be equal to a over x, and then there is a whole square. We talked about two possible rational functions, right? B over x minus 1 and cx plus d over x minus 1 whole squared. Okay. And this time you can do again hit and trial and guess the values of a, b, and c and d, but not very convenient again, or probably convenient, I don't know. So I let me solve it the usual way this time. The usual way would be, now you take the denominator and multiply on the other side. You are going to get a times x minus 1 whole squared, because only the x will cancel with that. B will go with get 1x and the x minus 1, because one of the x minus 1s will cancel, right? And cx plus d will only get x, because x minus 1 whole squared will be cancelled, right? And this one is in between, you can find some values by plugging in appropriate choices of x, and some you might have to solve more than one equation. Okay. For example, put x equal to 0, let's say. That's one obvious choice. And that is going to give you minus 2 equals a, 0 minus 1 is minus 1 whole squared will be 1. A, this whole thing will be 0 because there is bx, and that whole thing will be 0 because there is x at the end, right? Okay, you see the clever choice of x, the value for x. And that gives you a equals minus 2. One value obtained already. I'm sure you are seeing it. You'll put x equal to 1 next, right? And that gives you, if you put 1, 4 minus 2 will be 2 equals, again, a times 0 now, b times 0, because x minus 1 are factors there. And c plus d times 1. Okay, x equals to 1, so c times 1, 1, c plus d times 1. That gives you an equation C plus D equals 2. Now you are seeing it, no, it's not always that easy. Okay, so it doesn't give you a value of C or D directly, but it gives you an equation. What else? You have plugged in x equal to 0, you have plugged in x equal to 1. Now, putting anything else for x is not going to make the entire terms vanish, you know. So this is the time where you solve equations. Now you are going to plug in more values. Put x equals -1. Small numbers, okay, that is the best way to do it. You know, so -4 -2 will be -6 here, and -1 will be -2. A times -1 -2 whole squared will be 4, so 4a, and -1 times -2 will be +2, okay, plus 2b, and minus c minus d. X is -1, okay, and c times x will be minus c plus d. About there, minus, no, writing pen, minus c plus d. Okay, and when you plug in the value of a is -2, right? So -6 equals -8 plus 2b plus c minus d. So that gives you 2b plus c minus d equals 2. Okay, bring the minus to the other side. Okay, you have a second equation. We know the value of a already. We just have to solve for b, c, and d. So we will need 3 equations. We have 2 equations here, and you can see you're not going to be able to solve and for any of them yet. So you need one more. Okay. Put, now we have plugged in x equal to 0, x equal to 1, x equal to -1. 0, 1, -1, so natural choice is x equal to 2. Okay, when you plug in x equal to 2, you can plug in half, 1/3, whatever you want, okay? But those will make, you know, the equations more complicated, so I'm going with integer values. When you plug in x equal to 2, 4 times 2 minus 2, 8 minus 2, 6. 2 minus 1 is 1, so you get a there. 2 minus 1, 1, so 2b. And 2, so 2 times 2c would be 4c plus 2d. Okay? Plug in the value of a is -2. So 6 equals -2 plus 2b plus 4c plus 2d. And I will get 8. Okay, let me write the BCD on this side. 2b plus 4c plus 2d equals 8. Divide by 2, you get b plus 2c plus d equals 4. Okay. All right. But you'll notice that this is not going to be enough. Okay. And the reason this is not going to be enough is I can already see the 3 equations we have right now. Okay. C plus D equals 2. This and this. They are not independent. Okay. If you combine actually the first and the second equation, for example, C plus D, or the second and the third, both of them have B, right? Let's say I want to eliminate the B out of them. So, or I can actually go with the previous equation. Okay, if I want to eliminate the B, I will subtract the 2 equations, let's say I do equation 3 minus equation 2. Okay, like that, what I have written there. Equation 3 minus equation 2 will give me b and b will cancel, 2b, 2b. 4c minus c is 3c plus 2d minus d, minus d would be plus 2d. Sorry, plus 3d equals 6. And if you divide by 3, you get c plus d equals 2, which is already a equation you have, right? So if you combine two equations and it produces the third equation, they are not independent. The moral is that's not, we have to substitute one more value of x. Put x equals minus 2. See, you need to get independent equations. Okay. So if you plug in x equals minus 2, minus 8 minus 2 will be minus 10 equals minus 2 minus 1 minus 3 whole squared 9a and minus 2, so minus 3 times minus 2 6 plus 6b and minus 3 minus 3c plus 9c minus 3d. Okay, and then plug in the value of a. A is minus 2, so minus 18 plus 6b plus 9c minus 3d, and if you add that, 6b plus 9c minus 3d equals 8. Okay, and I'm going to take this equation and multiply it by 6 times 6. Okay, will give me 6b plus 12c plus 6d. Oh my god, that's also not going to help us. This is unfortunate. Okay, if I subtract again, I'm going to get, b and b will cancel. 3c, I mean subtract the other way around. Okay, lower minus upper. 3c, oh, or am I going to get something different? Let me double check I did not make a mistake here. If I get a different equation, I'll be happy. Okay. Oh, okay. Okay. Looks like I'm going to get a different equation, which is good news, because we had the other equation was c plus d equals 2. Now, if you make it 3c plus 3d, this will be 6, right? So when you subtract, you get 6d equals 10, which gives you d equals 10 over 6, which is 5 over 3. So it can be difficult. Okay, the takeaway here is you have to substitute. I don't know if I made a mistake because I was doing so many equations here, but the point is the technique I'm showing here is you substitute different values of x until you get enough many independent equations which you can solve and get the values of a, b, c, and d. Okay, how about I just say that and leave it there? Okay, all right. And what kind of factors can I expect depending on a is minus 2, so you'll have minus 2, ln x, and because of the minus sign, x can go to the denominator, so you can rule out this. X is in the denominator when you combine the ln, so it's either a or d. Okay, so they are also very similar, except now you have to see, what's the value of B. We need to know the value of B to choose between A and D, the options A and D. Okay. To know the value of B, were we able to solve it? No. We have to solve for that. Oh, looks like the Cx plus D parts are just 0. This X comes from the 1 here. Okay. This 1 here produces this X, right? Oh, okay. X minus 1 whole squared produces this. That comes from x minus integral of x minus 1 whole squared by applying the power rule. You get my integral of 1 over x squared is what? Minus 1 over x, right? That's where it comes from. Okay. So it looks like C has to be 0 and D has to be 1 or something similar to that. Okay. The values of C and D. Looks like I made a calculation mistake here then. Okay. When I substituted x equal to minus 2, let me check that again. Minus 10 equals 9a plus 6b. Oh, minus 2. Okay. I was making a mistake. I think I took x equal to minus 3 by the time I went to C and D. Okay. That was because x minus 1 was minus 3 and I was confusing that. Minus 9a minus 3 minus 2 plus 6b minus 2. Okay, these two I made a mistake. It should be plus 4c minus 2d, not 9. It is still 2. See, x is minus 2. Okay, so let me check with that. It will be 4c minus 2d, 4c minus 2d, and the 6b part doesn't change, right? Yeah. So when I subtract now, I get 8c. Okay, the equation here would be 8c plus 6 minus 2 is 4d equals 16. Okay, divide by 4, 2c plus d equals 4. All right, so I'm going to write in a different color now. C plus d is 2 and 2c plus d is 4. Okay, now when you subtract, you get c equals 2. That means d is 0. I was right about that. C is 2, d is 0. If c is 2, d is 0 here. This is 2 only. Okay. And if you plug in that, you will get the value of b also. C is 2, d is 0. So 2b plus 2 equals 2. So you get b equal to 0. So you don't get the x minus, b has to be equal to 1. How is that the case? B plus 2c plus d. Okay. All right. C plus d is 2. 2c plus d is 4, so c is 2, d is 0, which makes sense. But if c is 2 and d is 0, then b has to be 0. 8c plus 8d. Sorry. I made a mistake here. Okay. 8c plus 8d equals 16. And that will give me c plus d equals 12. Oh, okay. So even the x equals to minus 2 was not giving me an independent equation. It was giving me back the same thing. Sorry, here a lot of mess. Okay, you can see, solving equations is not easy. You have to do very carefully. I'm going to leave it at that. Okay, right now I'm not going to have time to do it. What I probably figure here is you have to plug in one more, x equal to 3. Okay, to get the answer. Then you will get one more equation probably and be able to solve it. Okay, so looks like a lot of mess there. All right. Anyway, I think I discussed the concept of how to obtain the partial fractions, and showed the process, how it is to be done. Requires a lot of work sometimes. I want to make another video I make will be on the strategies of integration, not the partial fractions. Okay, probably I will just solve some of them. I may not have time to make the video. I will make on strategies for integration by selecting some suitable problems. Okay, take care.